So I've decided to start doing several videos on computers, and we may get into a lot of other stuff as we go along. But this first video, I'm going to go over general circuit boards, how they work, and their design and everything. So this right here is a computer motherboard. It's for a specialized computer. We won't get into that, but I will get into the specific circuit board. This is called a circuit board. It's a printed circuit board, or PCB. And so we're just going to go over some general stuff. When you look at this, you actually see different colors in here, right? And sometimes it's called a solder mask. The plasticky stuff over, sometimes it'll be a different color. Here it's blue. You see red. I've seen green. Yellow. I mean, it can be any color you want it to. They're usually green. I don't really know why, but you can get other colors as well. So how they make a circuit board, there's actually different layers to it. The primary layers are made out of copper. They take a sheet of copper and they use a laser to cut it. So when you think of electrical components, let's say a light switch and a light, you connect it with a wire, or two wires actually, right? So the light switch is connected to the light. It's the same thing with these, except circuit boards have made it to where they don't have to actually physically wire things anymore. The components have become so small that a lot of the times you can't even get a wire to them. I mean, these capacitors here. You can see. Let's try to find some other stuff here. I mean, there's little computer chips there. Look at that. Those little computer chips. These right here, look at those. Those are actually transistors. But look how small they are. And if you look really close, and they're smaller than a grain of sand right in here, these are capacitors and resistors in there. And they used to be, the size of your thumb, and now they're so small you can barely even see them. So you can't attach wires to them anymore. So what they do is, instead of making physical wires, they just put them all on a PCB, a printed circuit board. So they take a sheet of copper, and if you look here, this lighter green color, that is actually, there's a layer in here of copper. So the green is not copper. That's a solder mask over it. But the lighter green is where you're seeing copper showing through it. So if you look here, look at these little components. You see the lines, the green lines that are kind of drawn out from each component? Those are little copper runs. All right, so they took a sheet of copper and they put it through their designs, and they use a laser machine and they cut them to where they get a sheet of copper that just looks like that. And so you'll see in here tons of them, little copper runs, and they get extremely thin, extremely flimsy, and so it takes a laser to cut them all like that. So you get this little sheet of copper, and you lay that out on top of a fiberglass layer that's an insulator. So we have a fiberglass. I don't know if we can look at the side of this board at all, but you can see in there, see that white? That is fiberglass. And there's a very thin line that you can see right in the middle. So you have two layers of fiberglass here over copper. So the fiberglass is an insulator, and it gives stability to the copper. But that's really all it's for. It doesn't have a function other than that. It's kind of like armor. It just protects you. And then you have the copper that lays on there, and they're the wires. And then you lay another sheet of fiberglass, and you have holes in the top sheet of fiberglass for components. This is hard to describe. So I might have a hole like this. And this is just for a little example, that goes through the fiberglass to the copper layer so that I can attach stuff on top of the fiberglass to the copper. And then you'll have a little piece of copper on top. It's called a copper pad. Here we go. It's called a solder pad. You see that? So these little holes here actually attached to the copper layer. And it allows you to solder stuff on there. And so on this printed circuit board, this run right here is probably something that they designed the board to be able to do, but I didn't buy that model, so they left it out. They use the same board, whether I buy the 1000 model or the 1001 model, right? And they just put different components on it. So that way they don't have to design 10 different boards. It's all the same board, they just use it differently. But anyway, so you can see those, they connect through to the copper layers. However, you can also have more than one copper layer. So let's say I need to connect this component right here to this component. Great, I'll just run a copper over, right? But what if I have to connect this component to this component? See how they're crossing, right? And so if I had a copper run on each one, the copper would be overlapping and they'd be shorting out to each other. So you end up having multiple layers. I might have one layer for certain wires to go from certain components, and then I'll have fiberglass, and then I'll have another layer to cross those. Some boards can have as many as 5 or 10 layers. It just depends. I mean, you can see all these are all complex. Those are different layers in there of copper. And again, they all go through their layers like this. And when we get into how a computer processor works, it's kind of the same thing, but it's shrunk down even more into almost the atomic scale. But it's the same concept. So when I'm talking about these solder pads that go through each layer, they may not go to the same layer. This one might go to the second layer of copper. That one might go down to the third layer of copper. But they connect to the top and give it a common run where we can attach to specific things. I mean, it depends on what this does, right? So that might be for communication or something. And so it'll connect to the different layers and different wires to the different components that it needs to perform that function. But it's all set on top, on the surface like this, to be easy to solder to, easy to use. And so all the runs come up like that. All of these components, I mean, they're so small that you can barely see them, but they all go down to different layers of the copper for different functions, to different wires. Some of them you can see, some of them are down in deeper layers that you can't see the actual runs coming from the components. And then you'll have some layers that are actually where the runs are underneath these other components. So they crisscross in 1,000 different ways. I mean, we're talking about a computer here. There's countless millions of copper runs here. And so they go through different layers. And when we get into how a processor works, you're going to see that there's trillions of connections, and I call them wires, but they're not wires, right? They're just little layers of copper. And when in the case of a processor, those layers are so small it's almost only a few atoms thick. And it's going to be an amazing video when I get there, but I'm not there yet. So we have a printed circuit board. All it is 50 years ago, all these components were by hand. They were vacuum tubes and huge hard drives and massive circuits that over time they shrunk down into these little computer chips and processor, and they were able to put them all on one board. So that's all it's doing is shrinking down. This would have taken up the space of an entire room 60, 70 years ago. I mean, well, it still wasn't possible back then, but if they had used the same stuff back then that they had back then to try to do this, it would have taken up an entire room. And now they've just shrunk it down to a printed circuit board. So a few other things I want to end this video. When we're talking about circuit boards, there's some things that you have to be aware of. So when we're looking at these copper wires, what happens if you take a wire and you put too much current through it? I mean, let's think about a light bulb, right? You got a light bulb and eventually it burns out, right? The little filament inside pops, melts, and it doesn't work anymore. That's what happens when you put too much current through a wire. Even the wires in your wall in your house, that's what breakers are for, to protect the wires, right? If you put too much current through them, they're going to get really hot, they're going to melt, and in your wall, they're going to start a fire. But when we're talking about a printed circuit board, what will happen is these little copper runs, if you put too much current through them, they'll pop, and you'll see a little black spot on the board. And this entire board's good. It's new, so I don't have any to show you. But so when you look over a circuit board that doesn't work, and you see a little brown or black burn mark, something put too much current through that copper and blew that circuit, so it's no good anymore. But anyway, so I want to talk to you because computer boards use most 90% of computers, 100% of desktops. When you're talking about these circuit boards, right? Most of them, especially your CPU, right, and your memory, they're running on what's called logic voltage. It's 5 volts. That's it. So you got minuscule amount of voltage, which means a minuscule amount of current going through this board. Now, let's say you go on a rug and you start rubbing your feet on a rug, what happens? You build static in your body. Well, static in your body can get as high as 20,000 volts when you go shock somebody. It takes that because there's extreme amount of resistance in your skin, right? So for you to actually pass current between you to another person through your skin, you got to have a very, very high voltage. The current isn't that high. You just get a little shock, right? But the voltage has to be immense to push the current through that much resistance, right? And we can talk about Ohm's law later and get into that and circuit design and stuff if I get there. But anyway, my point is, what happens if you put 20,000 volts to this board? What do you think would happen? It would blow like a light bulb. So you have to make sure when you're dealing with computer components that you know at least generally what voltage you're talking about. If I touch this and I had static in my hand right now, I would probably blow some components. I'd have 10, 20,000 volts from my finger rushing through all these little miniature copper runs, and they wouldn't last, they'd blow. So you're blowing a board with static. You don't want to do that. So whenever you're dealing with, especially printed circuit boards, when you know they're going to run on logic power, anything to do with computers, most of them are logic power, especially processors, you have to make sure you have no static electricity in your hands. You're completely discharged. So first of all, you see a rug right here, right? Well, I'm not on the rug, all right? So I'm not building static. I'm actually sitting on a wood floor. Well, it's fake. Well, no, this is real wood. But anyway, I'm sitting on a wood floor, all right? So you do not want to be doing anything with computers on carpet, nylon, or plastic, all right? You will build a static charge. So first of all, when I'm looking at this circuit board, I am off the rug. It is not on the rug. It looks pretty close, right? But I have this bag I'll talk about in a second underneath the board, right? It's protecting the board. So I will move that away a bit, but it's protected, all right? So it's not touching the rug. I'm not touching anything plastic, nylon, or floor or carpet or anything where I can build a static, or like rubber, like balloons and stuff, And the third thing is, when a lot of people deal with computer components, especially with circuit boards, they'll wear what's called a grounding strap. Usually it's a bracelet that goes around your wrist, and you attach it to something metal, and it grounds you out. I have never used grounding straps, ever. And I've never had a problem, but that's because I make sure first I'm discharged. So this right here we'll talk about later. This right here is a power supply. And when we get into circuits and how they're built, you're going to realize that power supply, when you plug it into the wall, there's 3 prongs, right? Positive, negative, and ground. The chassis, the outer case, is connected to that ground. So all you have to do is take your power supply, plug it in the wall, and touch that case, just like this. Just touch that. I can't reach it. I just touched the metal case, and now I'm discharged. And I know I'm discharged, so I'm safe to touch this circuit board. And once in a while, when I'm 20 minutes in, I might go touch it again. All right, just to make sure. But again, if I'm not sitting on floor and I'm not walking across the floor or anything, I should still be okay, all right? So just make sure you know about static, you know computers run on logic voltage, 5 volts, and if you touch a 20,000 volt finger to it, it's done. So we've gotten kind of into the basics of a circuit board. They're just a ton of circuits, right, that have been shrunk down and made easy to produce. All right, so that's it for this video. Next time, we'll try to get into maybe some of the circuit components, hard drive, and that right there, believe it or not, is the hard drive on this computer. It's shrunk down pretty good, right? We'll talk about those different types, different connectors for hard drives. I'm sure you're used to seeing the huge rotating hard drives. We'll talk about those. I might even take one apart to show you. I've got a few spares, so I can show you the insides of a hard drive, right? That's the computer processor. The processor chip, we'll take that out. We'll look at the other side. I'll discuss how they're made. That is the RAM, random access memory. Why do we need RAM if we got a hard drive? What's the difference? What's going on here, right? I'll talk about a lot of that. A lot of these other connectors, peripheral devices. How do they communicate? You obviously don't see a CD, DVD drive, or even a screen on this guy, right? So we'll talk about that stuff and how to add and subtract components. You see a lot of connectors on here, right? Well, there's 8 of them. That doesn't look right, even if you do know about computers, right? So this one's for a specific purpose. And as we go along and I describe all this stuff, I'll actually put this together, and that'll be part of the videos. This is for a Bitcoin mining computer. It's a very, very specialized computer. I had to design or order all the parts. Some of these are specially designed, the case and everything. And this guy is a graphics card. This guy is actually $3,000. We'll discuss this guy later too. One of the most powerful processors in the world inside that guy right there. So we'll talk about them later. Why do I need a graphics card if I'm running a Bitcoin mining machine computer? So anyway, we'll discuss all that stuff later. Computer fans, power supplies, all these different connectors. That right there is a heat sink. We'll discuss those and how to put thermal paste on there, how to put a computer together, take it apart. We'll discuss all that and the different voltages, how they're used. It's not all just 5 volts. Anyway, have a good one. I'll see you next time.